Good morning, students. In this lecture, I will teach you how to determine whether a standard form categorical syllogism is valid or invalid. The way we test their validity is by using three Venn diagrams. This is a lecture on page 100 of your textbook, so make sure you read that. Now, before before I show you how to test Venn diagrams, how to test syllogisms, we have to refresh our memories and talk about a couple of things. First of all, what is a standard form categorical syllogism? Well, remember that a categorical syllogism is an argument, a deductive argument that has two premises and one conclusion. So, three statements. But in order to be in standard form, it needs to satisfy certain requirements. And we talked about this in class, so you should remember what these requirements are. But let me just refresh your memory. First of all the statements must be in categorical form. All SRP, no SRP, some SRP, some SR not P. You remember the four categorical forms. That's very important. Another requirement is that the major term is always the predicate term of the conclusion. This is the major. And the minor term is always the subject of the conclusion. Naturally, the other term that never occurs in a conclusion is the middle term, and that in this case will be sweet things. So in this argument, all yellow things are sweet things, all bananas are sweet things, therefore all bananas are yellow things. Okay? This is the middle term. Okay? Middle term and middle term. Okay. This is a standard form categorical syllogism. Whether it's valid or invalid is something that we are going to find out soon. But before we get there, once again, I said a couple of things before we get there. The other thing that I wanted to remind you of is how to diagram statements. Okay. Eventually, in a minute, I'm going to show you how to diagram and test an entire categorical syllogism. But now, I just want to remind you of how to diagram a statement, a categorical statement. Remember that the categorical statement A, the A form, which states that all SRP is diagrammed by shading area 1. Remember, this is area 1, area 2, area 3, and area 4. Area 1 is the portion of S of the subject that does not overlap with the circle representing the predicate. So by shading, remember, by shading area 1, I eliminate all those members of S that are not, or that do not share any characteristics with P, with the other class, the other category. Our second form is the E form, and you remember, I'm going to go over this very quickly because we studied this in class and you remember, you should remember. The E form states that no S are P, and in order to diagram this statement that no S are P, I need to shade completely area 2. Our third form is the I form, which states that some S are P. So and remember, the I form is a particular statement. A and E are universal, so you use the shading. For I and O, which are particular, we use an X, because in both particular statements, I and O require some members. And you recall in logic, we express the sum, which means at least one, by using an X. Sorry, the X doesn't go there. Sorry. It goes in there, right? Because some S are P. Some S are P. So some, which is indicated by the X, some S are also members of P. And some P are members of S. That's what this means. Now, the last one, that's where the X goes for the last one, for the O form. The O form says that some S are not P. Some S are not P. So in that case, I need to draw an X, to place an X inside area 1 of S. Now, one important thing is the following. It doesn't really matter that to diagram an O form, I need an X right in the middle. As long as the X is inside area 1, okay, this is area 1, I can put an X over here, I can put an X over here, or over here, or over here. It doesn't matter. As long as you see, as long as it's not in area 2 and area 3. Okay? So remember this. Similarly, for an with regard to an I form, some S R P, okay? The reason is because it looks better. But again, the X doesn't need to be right in the center. The X needs to be inside area 2. So wherever you place it, right here, right here, right here, or there, here, or here, it doesn't matter. As long as you have one X inside that logical area. This will become clear later why I'm explaining this point. Okay? All right, so now that we remember how to diagram statements, and now that we remember what categorical syllogisms are, let's test a couple of syllogisms. Let me explain how to do it. First of all, let's start with any syllogism. Let's start with this one, with A, number 3. Okay. Remember that A3 is the A is the mood, And number 3 is the figure. So the mood tells you what kind of statements, and in this case we have 3 A statements. Okay, they are going to be in the A form, so all S are P. And I hope you remember what the figure is. If you don't remember, I refresh your memory. The figure of a syllogism is the position of the middle term. Remember that there are 4 figures, the middle term, and remember I gave you a trick to remember the figure, the W, remember? This is figure 1, this is figure 2, this is figure 3, and this is figure 4. Okay, so the tricky part is to remember which one is 3 and which one is 2. That's why I put 3 before 2, because 2, if you recall, is when both the predicates of a statement, of the major and the minor statement, are the middle term. Okay, so the second figure is middle term, all pushed down to the right, and then you come back to all the way to the left for figure 3, and then figure 4 is the opposite, okay, the negative of figure 1. Okay, but once again, you should remember this. Okay, finally, let's test this syllogism, the AAA number 3. How do we test it? Not taste it. Test it. We test it by using Venn diagrams. Now, here's the interesting part. We diagram a statement. A statement has a subject and a predicate. Okay, so we can use 2 Venn diagrams. But when we want to diagram a whole argument, the entire syllogism, which has 3 statements, we use 3 Venn diagrams. Let me show you how. First of all, I draw 3 circles. Oh boy, they're horrible. Well, they're not going to be perfect. You know, it's not easy to do it. Okay. Oh, that's good enough. Okay. So we have 3 circles. Let's label these 3 circles because remember that we have 1 circle per term. Okay, each term has its own circle. So the first term, I like. Now, of course, you can label. You can put any label that you want. You can call this circle middle term or subject or predicate. It doesn't matter which one, as long as you are consistent. Some textbook, for example, they draws the 3rd circle on top. I like to do it on the bottom. It's just a question of habit. You can do it whatever you want. Just the point is this: do not ever do this, because this is absolutely meaningless. This is not the Olympics. Okay. In order for the 3 statements to be related, you have to have 3 circles like this. 1, 2, and then the 3rd one that is related. Okay, this is better. You see? In this way, you connect all 3 terms. So I like to call this subject, this predicate, and the middle term is going to be the one on the bottom. Okay, now let's go back to our syllogism. We have an A3. In the exam, I will give you something like this. A3, EIO2, any mood, any syllogism, okay, completely described with mood and figure. What you have to do is reconstruct the argument, and then you diagram the argument right here. So let's reconstruct the argument. What do I mean by reconstruct the argument? You have to spell out the premises and the conclusion. What I suggest, what I recommend, is to start from the conclusion. I recommend starting from the conclusion. The conclusion is an A form, as you can see. Yeah. So let's start with the conclusion. All S are P. Okay. Once you have the conclusion, which is always the same, okay? Whether it's all or some or none, the conclusion is always S and P. Now you decide what goes into the second premise. This is the second premise. Remember then, the second premise is the minor premise. So, in the minor premise, you have to place the minor term. The minor term is always the subject of the conclusion. Okay. But you have to make sure that you consider the figure number 3. So before you place your terms, you think about it. Number 3. So it's 1. Remember, all the way to the right is number 2. And then you come all the way to the left and it's number 3. So the middle term is going to go right here and right here. Okay? 1, 2, 3, and then 4. We have number 3 right here. Now, in the second premise, what's missing now? What's missing is the minor term, which is S. There. Okay? So all M are S. And for the first premise, you know that you need the P. The P is the major, and the first premise is the major premise. Now we have the syllogism spelled out, written out, and all we have to do is to diagram it and determine the validity. Okay, so let me explain the idea of diagramming a syllogism. When we diagram the syllogism, essentially we diagram the statements, each statement one at a time, and we diagram it right here in this blank 3 Venn diagram that you can see. However, you don't diagram all the statements. You only diagram the premises. Some students feel tempted to diagram the conclusion. That would be an error. Never. Don't touch the conclusion. Leave the conclusion alone. Okay? Only diagram the premises one at a time. And then the idea is that when you look at the diagram, after the process of diagramming premise 1 and premise 2, you look at the diagram, and if you see the conclusion diagrammed as a result, then the syllogism, it means that the syllogism is valid. On the other hand, if you don't see the conclusion, then the syllogism is invalid. Let me demonstrate how, and then you will understand what I mean. But remember, once again, I cannot overemphasize this because students all the time do it. They diagram the conclusion. You don't diagram the conclusion. The conclusion, don't touch it, leave it alone. Okay. And one more thing that I wanted to say is that where do you start? Well, normally you start chronologically. Okay. We always start from number 1. That's our habit. We start from the beginning, and that's fine. That's the way it is. Later, I'm going to show you an example where we have a particular statement, and for example, a universal statement. So the particular statement is the first one, and the universal the second one. Now, if that's the case, if your first premise, the first premise of your syllogism is a particular one, by particular, you know what I mean. I mean either an I form or an O form. If that's the case, if the first premise is an I or an O, and the second premise is a universal, then you skip the first one and you start diagramming the universal first. But in this case, we don't have to worry because they're all universal, okay? So let me start with number 1. Now, when I say that we have to diagram number 1 inside here, what do I mean? Well, I mean exactly this. This is S, the subject, and this is the predicate. First premise is an A form premise. But the subject is M. And the predicate is P in this case. Okay? So how do I diagram all M are P? Well, you remember this. I explained it earlier. You shade area 1. Okay? You shade area 1. So here the trick, the tricky part, is going to be to identify area 1. Now, naturally, if I'm stating that all M are P, I have to look at M and determine which is area 1. And now, as you can see, M and P are kind of diagonal from one another. So you have to be able to rotate. On a notebook is easier to do that. You can rotate it back straight like this, and you can actually see the same thing that you see here. If you do it on a board like me, I have to be able to rotate my hand and look at this and see that area 1 is this. This is area 1. Okay? Or let me use the red marker. Let me use the red marker to show you. This is where area 1 of M ends. I hope you can see it. Okay, so essentially, when I say that we have to diagram the premise, I mean that first you have to visualize the premise. If that helps you, draw on your notebook the first premise, M and P, and then you shade area 1. So if that helps you, I don't need to do it. I can visualize it, okay? I can visualize it, and then I take that and I plug it in and I diagram it right there. Okay? So let's diagram it. Since this is area 1 and I have to shade area 1, let me shade all area 1. Okay, now I shaded area 1. As you can see, I have this thing here. If you focus your attention to M and P, it looks exactly like this, M and P. Okay? So that's the first premise. Now let's diagram the second premise. All M are S. Okay? Now you have to, you can see you have to, again, you have to rotate it like this. Okay? Rotate it like this. Because, once again, M, now the area 1 of M is going to be different. Because, that's obvious, right? Because the statement is different. The statement is between M and S. And so area 1, in this case, will end right there. So all this inside here is area 1. As you can see, area 1 is this triangle here, plus all this area up to here, which I already shaded. Okay? So I'm going to overlap the shading. That's fine. That's not a problem. Because I have to diagram what the premises say. By the way, let me just say this. What do you have to do? You have to diagram the premises exactly what the premises are asking you. Don't make up, don't try to adjust to make it convenient to yourself. You have to obey the orders dictated by the premises. If the premises says all M are P, that's just what you have to diagram. Don't try to diagram anything else. So, how do we diagram all M are S? Well, again, we have to shade area 1. Okay? See, this is why it's important. Remember, in class, I emphasize this point, that it's important that you master the various areas, logical areas, 1, 2, 3, and 4. For this reason, because you have to understand which one is the area. Okay? All right, we're done. We're done. Area 1, premise 1 and premise 2, we diagrammed them. Once again, do not feel tempted to touch the conclusion. Do not touch the conclusion. Do not diagram the conclusion. Only diagram the premises. And at this point is where you have to look at the diagram and decide whether the conclusion is diagrammed as a result. Remember, our conclusion is OSRP. OSRP. Or in other words, the conclusion, if this is S and this is P, in order for the diagram, for the syllogism to be valid, when you look at S and P on this diagram, you should see something like this. Well, not something like this, exactly this. You should see that S, that area 1 of S is completely shaded. But as you can see, area 1 of S, which is this one, okay, all this is area 1 Area 1 is not shaded. So what does that mean? It means it's not valid. It's invalid. Is it that easy? Yes, it is that easy. Now, let me give you another example, okay? Let's do another example. Let's try with this one. E 4. Okay. So E4 again. It's going to be no, everything no. No P or M, no M or S, and no S or P. So we label circle S, P, and M. Okay, and once again, we diagram only the premises. Only the premises. So the first premise, no P or M. This is P, this is M, and in order to make that statement, represent that statement, I need to shade area 2 between P and M. Second statement, no M or S. So this is S, this is M. So I needed to shade, okay? Shade the whole thing, shade the entire area 2. Even if there is already shading, okay? Overlap, don't worry about it, that's fine, okay? Now, once again, we don't touch the conclusion, and we ask, is the conclusion diagrammed as a result? No S or P. No, it's not diagrammed as a result. Not diagrammed. Because as you can see, area 2 is empty here. It's not diagrammed. Okay? All right, let's do another example. This time, let's do A2. No, we did A2. Sorry. We did 1. We did 1. I don't remember. Well, let's do A3 because I'm sure we didn't do it. A3. Okay. So all 1, 2, 3. All M are P. All M are S. All S are P. Okay. S, P, and M. Do it on your notebook as I'm doing on the board. Okay. All M are P. All M are S. Once again, conclusion, all S are P. Doesn't show up. Okay? Invalid, once again. Let's change this and see what happens in a figure figure 4. So all P are M, all M are S, and all S are P. And S, P, and M. Let's see what happens if we change mood, if we change a figure. All P are M, all P are M. All M are S. All S are P. No, not at all. Not at all. I don't remember if we did one, but I don't think so. I don't think we did one. One would be all M are P, all S are M, and all S are P. Let's see what happens. Okay, so once again, let's diagram these premises. All M are P. All S are M. All S are M. Now notice what happens now. What happens now is that the conclusion, I know that maybe it's tricky, it's not clear, but the conclusion actually is diagrammed as a result. Because what is the conclusion? The conclusion is all S are P. And remember that all S are P requires that area 1 of S is completely shaded. And it is. Okay? It is completely shaded. That it is. See that? That is completely shaded. And it also requires that between S and P there is communication, there's room. And in this case, there is room between the two. So even though half of area 2 is shaded, it's not the entire area 2 that is shaded. Consequently, this qualifies and it is valid. It is valid. Now let's change mood completely. Let me give you an example of a completely different mood. Let's say, let's start with an I. And the second one is an E, and we end with an A. I, E, A. Let's say number 1. Okay. All right. So first premise is some M are P. Second premise, no S are M. Conclusion, all S are P. Conclusion is always the same. All S are P. Okay. 2 and 3. S, P, M. Okay. All right, so remember what I said earlier. I said that when our syllogism begins with a particular statement, and remember that particular statements require an X, we skip that and we begin with the universal statement, if there is a universal statement. If they're both particular, then I'm going to show you later, next example, what happens. But why is this? Let me explain why. Because if we start diagramming a particular statement, that means we need to diagram an X, and the X means that there are some members of a certain class, but we don't know where the X goes. For example, if we start some M are P, now notice that since our diagram is completely blank, if I want to say that some M are P, where exactly do I put the X? I don't know where to put the X. I can place the X. Now, if some S are M, sorry, not P, I don't know why I said P. Some S are M. There are several places where I can put the X, remember? I have to place an X between S and M, but where? Do I put it here or here? I don't know. Why do I say that I don't know? Well, I don't know because the premise 2, does not specify where I should put the X. It only says there is an X between S and M, but where? Now, if I put it here, you see, the problem is this. Let's say that I decide and I place it right here. And you say, okay, well, you're diagramming the premise, okay? However, by placing an X there, I'm also saying something else. I'm also diagramming another statement. I'm diagramming that some S are not P. You see? Some S are not P. I hope you see it. Because remember that the O form has an X inside area 1 of S. It doesn't matter what it is, whether it's here or there or there. So I'm diagramming something else. And the problem is that, remember what I said, you have to obey the rules dictated by the premises. So if the premise says something specific, you have to diagram specifically. And you can't do that because the only thing that premise 2 is saying, is asking you to do, is to diagram that the first premise, some S are, okay, now I completely messed up. Okay. We're talking about the first premise, okay? Sorry about the confusion. So, some M are P. Some M are P. So, I was right the first time, and I corrected myself. So, some M are P. Where do we put the X to indicate that some M are P? Either here or there. Now, if I put it here, I diagram that some M are P. That's true. But at the same time, as you can see, I'm also diagramming that some S are P. But that's not what the premises ask for. Okay, so not here. What about here? Well, if I place an X right there, once again, I do diagram that some M are P. However, I also diagram that some P are not S. And that's not what I need to diagram. Now, there's another option. there's a third option. The third option is that I place it in between. Okay, so if I place it in between on that line, essentially I'm not diagramming anything. I'm only saying that I don't know where it goes. Some textbook, your textbook in particular, doesn't do the X like that, but it uses the concept known as the bar. Okay, so the bar means we don't know. Okay, but before we venture to diagram the first premise, as I said, which we have no specification, we don't know where to put the X. Let's skip the first premise and let's diagram the second premise, which is a universal premise. Okay, so no S or M. All right, so now I know what to do because I just have to shade area 2 between S and M. And that's easy. That is not a controversial diagram, okay? Now you see what happens? Now by shading area 2, that allows me to decide what to do with this X. So I'm going back now to premise 1, sum M R P. Now you see what happened now? Now I can precisely indicate with an X the sum M R P, because there's only one place where I can put the X right now, and that place is here. Why do I say that there's only one place now? Because I shaded this part. So this part here is completely gone. There's nothing goes in. Remember? The shading does not permit anything to go in. So the only place to put the X now is in the empty space. And now I precisely diagram the conclusion. Okay, now, once again, we diagrammed our premises. Let's see if the conclusion shows up, if the conclusion is diagrammed as a result. All S are P. No, it's not. It's not diagrammed as a result. Now let's work out another example. Let me do this. IEO 1. Okay. So conclusion is going to be sum S R not P. Second premise is no S or M. First premise, sum P, no, sum M or P. Okay, sum M or P, because this is figure 1. Okay, now, S, P, and M. Okay. All right, once again, we don't start from premise 1 because premise 1 is a particular one. It requires an X. I don't know where to put the X. So let's start with the universal premise. No S or M. No S or M. Now let's go back to premise 1. Sum M or P. Okay, now once again, like in the previous example, I have the only one space, so I can precisely make the statement, diagram the statement sum MRP because we have the X inside there. Now the question is the conclusion diagrammed as a result? No, it's not diagrammed as a result because some S are not P. You would have to have an X anywhere here to diagram this some S are not P. Okay, so that doesn't work. Now, watch what happens if we change the figure. Instead of figure 1, we do figure 4. So in figure 4, we have some S are not P, the conclusion, no M are S, and some P are M. S, P, and M. Okay. All right, so let's start with the universal, no M or S. No M or S. Okay. Then we go back to premise 1. Some P are M. Good. No M or S. Yeah. Okay. Again, does the conclusion follow? No, it doesn't. It doesn't follow. Some S are not P. Okay. So let's do another experiment. Let's do another experiment. Let's try with number 3. See what happens. So now in number 3 we have some S are not P. No, number 3, remember, is 1, 2, and 3. No M are S, and some M are P. So, as usual, no M or S. We shade area 2. Now, we go back here and some M are P. Some M are P. Okay, conclusion, some S are not P. No, not good. The conclusion doesn't show up. The only let's do one last try, and let's do 2. P, no S or M, and some P SPM. Okay, so no S or M. Some P are M. No, yeah, some PRM. Some PRM, same story goes here. Nothing changes. Okay. Once again, not valid. Now let's change completely and see what happens. Let's have a AII3. Okay. AII3, so we have sum SRP, sum MRS, and all MRP. Okay. All right. So now we have all MRP. All MRP. And some MRS. Some MRS. This is M, this is S. Okay. So in order to say that some MRS, I have only one place that I can use where I can place the X, and it's right there. Okay? Now, did you see what just happened? See what just happened? That as a result of my diagram in the premises, finally I get a valid argument because conclusion says some SRP. And that's exactly what I read. I read as some SRP. Yes, some SRP. Okay? All right, let's do one more example. And then, let's see, one more example. All right, let's try something like this. EAI number 3. EAI3. Now, what I'm going to show you here is something a little different. Let's first reconstruct the argument. Some SRP. All MRS and no MR. Okay, so we have both universal premises, so we don't have to worry. We can start from the first one. No MRP. No MRP. And all MRS. All MRS. Okay. I don't know why I did it this side, but anyway, that's fine. The point is, this is okay. It's all shaded. This is shaded too. All right, so now, as you can see, in this case, we have a an invalid argument. It's invalid because to be valid, you should see the conclusion as some S are P. So between S and P, you would have to have an X, and there's no X. Can you put an X there? No. Why? Because the premises, remember, we are diagramming the premises, precisely what the premises say. And the premises don't say, do not require an X. So we don't put an X, okay? So this is just an invalid argument. Done. That's it. Okay. Then, let's try something different. EAI 1. Right, so some SP all S are M and no M are P. Let's see if there's a difference. All right, no MRP, no MRP, shade this, and all S are M. This time, all S are M. Okay. Well, as you can see, the conclusion some S are P, that this diagram would prevent it completely because the area 2 where the X would go is completely shaded, so there's no X. That's it. All right. Now let's do one more example. A E O 2. A E O 2. All right. So some S are not P. No S are M, and all P are M. So all P are M. All P are M. P are M. And no S are M. No S. No S are M. Okay. Once again, conclusion, some S are not P. Some S are not P. Okay. There's no X. Fine. The syllogism is invalid. Okay. Well, I think I want to end here, and remember this EAO2 because in the next lecture I want to show you that EAO2 is invalid, but in fact in logic this type of syllogism is known as conditionally valid. Let me put it right here. It's known as conditionally valid. So in the next lecture, we are going to learn what a conditionally valid syllogism is. Also, in the following lecture, I will teach you how to diagram non-standard form categorical syllogisms. Non-standard form, the type that I have in mind is known as sorieties. Now, sorieties is both plural and singular. So one sorieties, two sorieties. Okay, sorieties are chain of enthymemes. You recall what an enthymeme is? An enthymeme is an argument that misses either a premise or a conclusion. In this case, sorieties are chains of syllogisms that are missing a premise and a conclusion. So the first diagram misses the conclusion, and we have to derive the conclusion. We have to infer the conclusion, and that conclusion will be, in its turn, it will be the first premise of the next syllogism. So sorieties are arguments that have more than 3 premises, 4 or 5. And the reason is because, as I said, they are syllogisms, so chains of enthymemes that are missing a premise and a conclusion. I'm going to explain that in the next lecture. Thank you for now, and I'll see you next time.